Hi everyone, welcome. Today we're looking at multiplying monomials. That's from Unit 7.1. We're going to be skipping to Chapter 7 for a little bit, a couple units we need to do there to get some background information for some other stuff that's coming up earlier in the book. But looking at this, two learning targets that we have. One is I can identify monomials. And then our second learning target is I can multiply monomials. So after we're able to identify what they are and learn about them a little bit, then we will be able to multiply them together as well. So that's what our targets are for now. So let's look at it. First, what a monomial is. A monomial is a number, a variable, or it could be the product of a number and a variable that has a non-negative integer exponent. So understand there cannot be any negative exponents, and the exponent has to be an integer as well. A monomial has only one term, so there aren't going to be any plus signs or minus signs, or you can't divide by anything that's got a variable in the denominator. And some examples are as here. We have 3x, 3xyab. You could have 3xyab over 2, different things like that. But again, you cannot have a variable in the denominator. That would make it something other than a monomial. And you can't have a plus sign or a minus sign or anything like that, because that would put two terms together. A monomial can only be one term. Mono, again, is a prefix that means one, so we can only have one term. So again, it's a number, variable, or product of a number and a variable with a non-negative integer exponent. And a monomial has only one term and cannot have any variables in the denominator. Have three rules when we're dealing with these things. First thing is the product of powers. If you're going to multiply two items together that have an exponent, if they have the same base, then you would just simply add their exponents. So that's what we're talking about with this. You notice we have a base of b in both cases, so b to the third power times b to the second power means we're going to add the exponents. So it's b to the fifth. It's not b to the sixth. Notice that for sure, that in this case we're not multiplying the exponents, we're adding them together because we have the same base, and if we add the exponents together we'll be in the right place. So this would be b to the fifth power. The second thing is called a power of a power, and what we're looking at there is we're going to, in this case, multiply the exponent. So this is when you have something in parentheses, you're going to multiply by the power on the outside, whatever's inside. So here we have b to the third inside the parentheses, and we're taking that whole thing to the second power. In this case, we do multiply the exponents. And if you think about it, b third to the second power is the same as saying b to the third times b to the third. And then if we multiplied b to the third times b to the third by the rule we just learned a second ago back up here, the product of powers, we would add those two exponents together. So we have b to the third, or b to the 3 plus 3 would be b to the 6. Same way here, if you have items in parentheses and you multiply them together, you're raising them to a power that's outside the parentheses, you are going to go ahead and... Hi everyone, welcome. Today we're looking at multiplying monomials. This is from chapter 7. We'll be looking at 7.1 and 7.2 over the next couple days, and then we'll get back to more toward the beginning of the book. But we have a couple of things we need to learn here about monomials that will help us with other things we're going to be doing in the class. So first, two learning targets. One is I can identify monomials. I need to know what they are. And second, I can multiply monomials. So after we learn what they are, we'll show you some rules to be able to multiply them quickly and easily. So first, a monomial definition, it's going to be a number, a variable, or the product of a number and a variable with non-negative integer exponents. So again, look at that carefully. When it says non-negative integer exponents, we cannot have any negative exponents, and the exponents would have to also be an integer. So we're looking at an exponent something like 2, 3, 4, 5. No negative ones and no fractions. A monomial has only one term and cannot have any variables in the denominator. So if you see something that has a variable in the denominator and it's in its simplest form, that will not be a monomial. Some examples of ones that would be considered to be monomials are 3, 3x, 3xy, ab. Notice you can multiply things together, that's fine. And if you do have anything in the denominator, it cannot be a variable. Okay. 3 rules in dealing with these. First thing is called the product of powers. To multiply two powers that have the same base, we're going to add their exponents. So in this case, we have b to the third times b to the second. When we multiply them together, that is going to come up being b to the fifth. Okay, so it is not b to the sixth. We're not going to multiply the exponents. In this case, it's b to the 3 plus 2, or b to the fifth power. And if you think about it, if you had, let's take something that we know what it would be. If we have 2 to the second power, and we're going to multiply that times 2 to the third power, by these rules, that would be 2 to the fifth power. Let's see if that works. 2 to the third power is 8. 2 to the second power would be 4. 8 times 4 is 32. So let's just test that out. If we multiplied 2 times 2 times 2 times 2 times 2, that also would equal 32. So that would prove for us that we would add the exponents when we're multiplying items with the same base. So again, just to restate that, if we said 2 to the third and we multiplied that times 2 to the second, that would equal 2 to the fifth, which is the same as 32. Notice how it's not 2 to the sixth, it's 2 to the fifth. Okay, now let's look at the second rule. Is called the power of a power. And I'm looking right up here now, and that's what we're talking about then. In this case, to find the power of a power, we're going to multiply the exponents. So if we have something inside parentheses and we're raising that to a different power, or any power, what we would do in this case is we would multiply the exponents to get the correct answer. So if we have b to the third and we're taking that to the second power, and think about what we're really doing here. In this case, we're taking b to the third times b to the third. And if we did that going back to rule number 1, which we just learned, we would add those. 3 plus 3 is 6. So it does make sense that both of these would work out. So if you have something in parentheses and you're raising whatever's in parentheses to another power, in that case you will multiply the exponents together to get the correct answer. Third rule is called the power of a product. So we're looking right here. And to find the power of a product, we're going to find the power of each factor and then multiply. So in this case, looking over at the letters first, we have a b to the m power. It's just going to be a to the m power times b to the m power. So if you think about it, it's really like rule 2, but since we don't have any exponents showing in this particular example, this would be a to the first and b to the first. We don't list the first power, we don't show it as an exponent, but essentially it's there, and number just sitting by itself is in fact to the first power. So what we're doing now then is just multiplying m times 1 and we get m, and over here we're multiplying m times 1 again and we get m for this exponent. So that's how the power of a product works. Whatever you have inside, you're multiplying by the power that each factor is applied to, and then you multiply those numbers together on the outside. So let's look at one that has some numbers and has some exponents inside too. So 3xy squared, and then that whole thing is raised to the third power. So we take 3 to the third power, we would take x to the third power, and we would take y to the sixth power again. We basically multiplied exponents. 3 times 1 gave us 3 here, 3 times 1 gave us 3 here, and 3 times 2 gave us 6 here. Now we just simplify as far as we can. Well, we know 3 to the third power is 27. Again, that's 3 times 3 times 3. And then x to the third power, y to the sixth power. We can't combine those anymore because they're not like terms. But we will be finished then with this answer, 27 x to the third, y to the sixth. So these are some, basically what we've done in this one is identified what a monomial is, giving you some rules for that. And we've looked at 3 particular rules that you need in order to multiply monomials. So hopefully it'll be a little bit helpful, and I'll look forward to talking to you soon about it. This one's a little longer than most of them, but we wanted to get some of these points across and give you a good reference tool to use. Thanks very much. Take care. We'll talk to you real soon.